now listening to Cassphere Podcast.
All right, so today we're taking a deep dive into a field that's kind of quietly changing the way we interact with technology. Natural language processing.
NLP?
NLP, that's right. NLP for short.
You know, it's funny. NLP is one of those things that's like quietly become a part of our everyday lives.
Oh, yeah.
From, the chatbots on websites to the predictive text on our phones. It's almost like we're having a conversation with our devices these days.
It really is, yeah. And for this deep dive, we've got like a whole stack of research papers, articles, all that.
Oh, wow.
We're going to uncover how NLP actually works.
Great.
Think of it as like learning the secret language of computers.
I love it. You know me, I love a good origin story.
Yeah, you do.
So we'll even be taking a trip back in time to explore like the fascinating history of NLP.
Right.
We're talking Turing tests and early chatbots that, believe it or not, fooled some people into thinking they were talking to real humans.
Wait, seriously?
Oh, yeah. It's wild.
I got to hear more about that.
We'll get there.
But first, like for those who might be new to this whole NLP thing, let's break it down.
Okay.
What are we even talking about when we say natural language processing?
At its core, NLP is all about enabling computers to, understand, interpret, and even generate human language.
Okay.
Think of it as bridging the gap between the way we communicate and the way computers process information.
So it's like teaching computers to like speak our language.
Yeah.
But not just speak it, but like understand it.
Yeah. Yeah, exactly.
Like get the nuances, the slang, maybe even the sarcasm.
Exactly. And that's no easy feat. Human language is incredibly complex, full of ambiguities and subtleties.
For sure.
But over the decades, researchers have developed some truly ingenious techniques to tackle this challenge, leading to the sophisticated NLP models we have today.
Okay, speaking of models, I keep hearing about these things called transformers.
Yeah.
They sound pretty important.
They are.
But I have to admit, the whole concept is a bit of a mystery to me.
They're definitely the rock stars of the NLP world right now.
Okay. They've revolutionized how we process language, and we'll definitely be, unpacking how they work in detail. But think of them as super efficient information processors that can analyze entire sentences at once, understanding the context of each word.
So it's like they can read between the lines just like we do.
Exactly.
Wow, that's amazing. But before we get too far ahead of ourselves, let's step back and explore how this whole NLP journey began.
Ah, yes, the early days of NLP.
Yeah.
Picture this.
Yep.
It's the 1950s.
Okay.
And researchers are just starting to explore the idea of machine translation.
Oh, okay.
Imagine trying to teach a computer to translate languages when even the concept of a computer was still relatively new.
I can only imagine the frustration.
Oh, it was.
It's like trying to explain a joke to someone who doesn't understand your culture, sense of humor.
It's a great analogy because those early attempts at machine translation were definitely a bit clunky,
They relied heavily on handcrafted rules, which meant programmers had to painstakingly define every grammatical structure, every vocabulary word.
Oh, right.
It was a monumental task, and ultimately, it just wasn't scalable.
Yeah, it sounds incredibly tedious, honestly.
It was.
Did they make any progress with this, rule-based approach?
Believe it or not, they did. In 1966, a chatbot named Eliza was developed at MIT.
Yeah.
And Eliza was designed to simulate a Rogerian psychotherapist.
Okay.
And it actually fooled some people into thinking they were talking to a real human.
No way. So in the 60s, they were already creating chatbots that could, pass the Turing test.
To some extent, yeah.
That's pretty mind-blowing. What was the secret to Eliza's success?
Well, Eliza didn't actually, understand the meaning of what was being said.
Okay.
It relied on, clever pattern matching and keyword recognition to formulate responses.
Okay.
For example, if you typed, "I'm feeling sad today," Eliza might respond with, "You're feeling sad today. Can you tell me more about that?"
Ah, so it was more about creating the illusion of understanding rather than, true comprehension?
Exactly.
Still, it's a pretty impressive feat for the time.
Oh, absolutely. Eliza was a major milestone in the development of NLP, and it really paved the way for future chatbot innovations.
Yeah.
But, the limitations of rule-based systems were becoming increasingly apparent.
Yeah, for sure. So what happened next? Did researchers finally figure out how to like teach computers to truly understand human language?
Well, not quite.
Okay.
But there was a major shift in the approach to NLP in the 1980s and 90s
Okay.
with the rise of statistical methods.
Oh.
Instead of trying to program every single rule of language,
Right.
researchers started using statistical models to analyze vast amounts of text data.
So it's less about like dictating the rules and more about letting the computers kind of learn from the data itself.
Exactly.
Kind of like how we learn language through exposure and experience.
Yeah, exactly. This data-driven approach led to significant progress in areas like speech recognition and machine translation.
Okay.
The models could, learn patterns and relationships from the data, leading to more accurate and nuanced outputs.
That makes sense.
Yeah.
But even with statistical models, I imagine there were still challenges in capturing the full complexity of human language.
Oh, definitely. But then in the early 2000s, the field of NLP experienced another seismic shift with the advent of neural networks and deep learning.
Okay.
This was a game changer, allowing for the development of even more sophisticated and powerful NLP models.
Okay, so neural networks,
Yeah.
those are the ones that are loosely inspired by the human brain, right?
That's right.
I've heard they're behind, like a lot of the recent advances in AI.
Absolutely, yeah.
So how did neural networks kind of change the game for NLP? Was it like a gradual evolution or a sudden breakthrough?
There were definitely some key moments that propelled neural NLP forward. One of the early breakthroughs was word-to-vec, a technique developed in 2013 that revolutionized how we represent words.
Word-to-vec.
Yeah.
That name rings a bell, but I can't quite recall what it's all about.
Okay, so think of it this way.
Okay.
Imagine you have a giant dictionary, but instead of definitions, each word is associated with a unique set of coordinates
Okay.
in a multidimensional space.
Okay.
This vector space is organized so that words with similar meanings are clustered together.
So it's like giving each word a unique fingerprint
Yeah,
based on its meaning.
exactly.
That's a pretty clever way to represent words.
It is. And word2vec paved the way for even more powerful neural NLP models, like the ones that power many of the language technologies we use today.
Okay.
But the real turning point came in 2017 with the introduction of the transformer architecture.
Ah, yes, the famous transformers.
Mhm.
We've come full circle.
We have.
Tell me, what makes these transformers so special?
Well, they're incredibly efficient at processing information and understanding context. They can analyze entire sentences at once, paying attention to the relationships between words and capturing those subtle nuances that make human language so complex.
It's like they have a superpower for understanding language.
They do.
Like they're reading between the lines and picking up on all the subtle cues that we humans just take for granted.
Exactly. And this ability to understand context is what makes transformers so powerful.
Okay.
They've revolutionized tasks like machine translation, text summarization, question answering, even creative writing.
Wow.
Yeah,
Okay, so transformers are clearly a big deal.
they are.
But I still feel like I'm only scratching the surface of how they actually work.
Sure.
Can we dive a little deeper into the mechanics of these models?
Absolutely. Let's unpack the magic behind transformers.
Right.
At the heart of these models lies the concept of self-attention.
Okay.
It's like giving the model a superpower to focus on the most relevant parts of a sentence, understanding the context of each word based on its relationship to all the other words around it.
So it's like they're reading the sentence with a deep understanding of how the words relate to each other,
Yes.
just like a human would.
Precisely. Think of it this way.
Okay.
Imagine you're reading a sentence with the word bank.
Okay.
You instinctively know whether it refers to a financial institution or a riverbank based on the surrounding words, right?
Yeah.
Self-attention allows AI to do the same,
Okay.
making it much more intelligent in its processing.
That's a great analogy.
Yeah.
It finally makes sense to me why transformers are such a game changer.
They are.
They're not just processing words in isolation.
Right.
They're understanding the whole sentence, the context, the relationships between words.
Exactly.
It's like they're finally starting to think like we do.
And that's what makes NLP so fascinating.
Yeah.
We're essentially teaching machines to think and communicate like humans, which opens up a world of possibilities for how we interact with technology.
It really does.
Yeah.
So now that we've got a grasp on the history of NLP and the power of transformers, what's next on our deep dive agenda?
Well, I think it's time we explore some of the specific techniques that make NLP possible. Those behind-the-scenes processes that allow computers to break down language into manageable chunks.
Right.
We're talking about things like tokenization, normalization, stemming, and lemmatization.
Ah, yes, those technical terms.
Yeah.
I've seen them mentioned in the research papers.
Okay.
But I'll admit, I'm a little fuzzy on the details.
Sure.
Let's break them down, shall we?
Absolutely. Let's start with tokenization.
Okay.
Think of it as chopping up a sentence into individual words or even subwords.
Okay.
It's like taking a sentence and breaking it down into its basic building blocks.
So it's like taking a whole pizza and slicing it up into individual pieces so you can actually eat it.
That's a great analogy.
Okay, great.
And once we have our tokens, we need to normalize them.
Okay.
This involves converting the text to a standard format, like lowercase, and removing punctuation. It's like, cleaning up the data, making sure it's consistent so the model isn't thrown off by superficial variations.
So it's like making sure all the pizza slices are roughly the same size and shape so they cook evenly?
That's another great one, yeah. Consistency is key.
I like it.
And then we have stemming and lemmatization, which are both ways of reducing words to their root form.
Okay.
Stemming is like a simpler approach that just chops off the end of words.
Okay.
So jumping, jumps, and jumped would all be stems to jump.
Okay.
Right.
Sounds efficient, but maybe a bit rough around the edges.
Right. Lemmatization is a bit more sophisticated, It uses dictionaries and grammatical knowledge to find the base form of the word.
Okay.
So better would be lemmatized to good.
Okay.
It's like finding the most elegant way to express the core meaning of a word.
So it sounds like there's a trade-off between speed and accuracy when it comes to stemming and lemmatization.
There is. The choice of which technique to use often depends on the specific NLP task at hand.
Okay, that makes sense. So now that we've got our text nicely prepped and processed,
Yeah.
what happens next?
Yeah.
How do we actually train these NLP models to understand and generate human language?
Well, that's where the real magic happens. We're talking about training montages, massive data sets, and algorithms that can learn from vast amounts of data.
Okay.
But we'll have to save those juicy details for the next part of our deep dive.
Ooh, cliffhanger. I guess I'll have to wait with bated breath to find out how these models actually learn.
You will.
But I have a feeling it's going to be worth the wait.
It will be. Welcome back. So are you ready for that training montage?
Oh, I'm always up for good training montage.
Oh, right.
But seriously, I'm really curious about this whole model training process.
Yeah.
It sounds incredibly complex.
It definitely can be. But at a high level, it's all about, feeding the model massive amounts of data.
Yep.
And letting it learn patterns and relationships.
Okay.
Imagine showing a child thousands of pictures of cats and dogs. Eventually, they start to distinguish between the two.
How then?
It's similar with NLP models,
Uh-huh.
except we're feeding them text and code instead of images.
So it's all about exposure and repetition.
It is.
The more data the model sees, the better it gets at understanding language.
Exactly. And the data sets used to train these models are truly mind-boggling in scale.
Okay.
We're talking about billions of words and sentences scraped from the internet, books, articles, you name it.
Wow, that's a lot of data.
It is.
I can't even imagine trying to read that much text in a lifetime.
Right.
But how does a model actually learn from all this data?
Yeah.
Is it just memorizing everything it sees?
Not quite. It's more about identifying patterns in relationships.
Oh.
For example, a model might learn that the word cat often appears near words like meow, feline, or whiskers.
Okay.
And over time, it builds up this complex understanding of how words relate to each other and how they're used in different contexts.
So it's not just about memorizing definitions.
Right.
It's about understanding the nuances of language.
Yeah.
The way words are used in the real world.
Precisely. And this ability to understand context is crucial for tasks like machine translation.
Okay.
Imagine trying to translate a sentence like, I'm feeling blue today.
Yeah.
A simple word-for-word translation might not capture the intended meaning.
Right.
A good NLP model, however, would understand that feeling blue is an idiom that expresses sadness.
Right. Yeah, that's a great example.
Yeah.
It highlights how important it is for these models to go beyond just the literal meaning of words
Absolutely.
and understand the deeper nuances of language.
Yes.
But how do we actually train them to do this?
Right.
Is it Like teaching a human language with like grammar lessons and vocabulary drills?
Well, it's not quite that straightforward. There are different approaches to training NLP models.
Okay.
But one common method is called supervised learning.
Okay.
This involves feeding the model labeled data.
Okay.
Which means we provide it with examples of text. Okay.
Along with the desired output.
So we're giving the model a set of training wheels.
Yeah.
Showing it what we want it to learn.
Exactly. For example, we might feed the model thousands of restaurant reviews labeled as either positive or negative.
Okay.
The model then learns to associate certain words and phrases with positive or negative sentiment.
And then, once it's trained on this labeled data, it can analyze new restaurant reviews and predict whether they're positive or negative.
Exactly. And this type of sentiment analysis is just one example of how supervised learning can be used in NLP.
Okay.
It can also be applied to tasks like text classification, part of speech tagging, and even machine translation.
It sounds like a very powerful technique.
It is.
But I imagine it can be quite labor-intensive to create all that labeled data.
Yeah.
Especially for complex tasks.
It definitely can be.
Yeah.
And that's why there's been a growing interest in unsupervised learning techniques for NLP.
Okay, so unsupervised learning.
Yeah.
What's that? So in unsupervised learning, we don't provide the model with labeled data.
Okay.
Instead, we let it learn patterns and relationships on its own.
Okay.
From vast amounts of unlabeled text.
So it's like throwing the model into the deep end and saying, okay, figure it out.
In a way, yes, it's a bit more challenging, but it also allows the model to discover patterns that we might not even be aware of.
Right.
And it, eliminates the need for labor-intensive data labeling.
That's pretty amazing. But I have to admit, it's hard to wrap my head around how a model can learn without any guidance or instruction.
It is. It's a bit mind-boggling. But there are, several clever techniques for unsupervised learning in NLP.
Boy.
One approach is called word embedding, which we touched upon earlier with word2vec.
Ah, yes, the word fingerprints.
Yes.
Remind me, how does that work again?
So word embedding involves representing words as vectors in a multidimensional space.
There we go.
And words that are similar in meaning end up clustered together in this space. For example, happy, joyful, and cheerful might all be located near each other, while sad would be further away.
So the model is learning to group words together based on their meaning?
Yeah.
Even though we haven't explicitly told it what those meanings are.
Exactly. It's like the model is creating its own internal dictionary based on the patterns it observes in the data.
That's fascinating. And once the model has learned these word embeddings,
yeah,
what can it do with them?
Well, they can be used for a wide range of NLP tasks.
Okay.
For example, they can be used to improve the accuracy of machine translation by helping the model understand the subtle differences in meaning between words in different languages.
So word embedding is like giving the model a deeper understanding of the semantic relationships between words, even across different languages.
Exactly. And it's just one example of how unsupervised learning can be used to train powerful NLP models.
Okay.
There are many other techniques out there, and the field is constantly evolving.
Yeah, it sounds like there's a whole universe of possibilities.
Yeah, there is.
When it comes to, training NLP models.
Yeah.
But once the training is complete, what happens next? How do we actually put these models to work in the real world?
Well, that's where things get really exciting. We can use trained NLP models for, a wide range of tasks.
Okay.
From powering intelligent chatbots to translating languages to generating creative text formats.
Okay, let's dive into some, specific examples.
Sure.
I'm curious about how these models are actually being used in both professional and entry-level settings.
Okay, so in professional settings, NLP models are being used to automate complex tasks, improve efficiency, and even create new possibilities.
Okay.
For example, in the legal field, they can be used to analyze contracts, identify potential risks, and even generate legal documents.
Wow, that's impressive. It sounds like these models are capable of handling some pretty sophisticated tasks.
They are.
What about entry-level applications? How are people using NLP in their everyday lives?
Well, think about the last time you used a chatbot on a website or interacted with a virtual assistant on your phone.
Yeah.
Chances are you were interacting with an NLP model.
Right.
These models are becoming, increasingly commonplace.
Yeah.
Providing us with convenient and personalized experiences.
It's true. I use chatbots all the time to, get quick answers to my questions or troubleshoot technical issues.
Yeah.
They're incredibly helpful.
They are.
But I never really stopped to think about, the sophisticated technology that powers them.
It's easy to take these technologies for granted.
Yeah.
But it's worth appreciating the ingenuity and complexity behind them.
Yeah.
And the exciting thing is that NLP is still a relatively young field, with new discoveries and applications emerging all the time.
It really feels like we're on the cusp of like a new era in human-computer interaction.
Yeah.
Where language is becoming the primary interface.
It is.
It's pretty mind-blowing.
It is.
But I'm curious, what are some of the most cutting-edge NLP models out there right now? What are like the rock stars of the NLP world?
Well, we've talked a lot about transformers.
Yeah.
And for good reason.
Yeah.
They've been incredibly influential, and models like BERT and GPT-3 have really pushed the boundaries of what's possible with NLP.
Oh,
BERT, for example, is used in Google Search
okay.
to understand the intent behind your queries and deliver more relevant results.
So BERT is like the brain behind Google Search,
Yeah.
helping it understand what we're really looking for.
Exactly.
That's incredible. What about GPT-3? I've heard a lot of buzz about that one.
GPT-3 is another powerhouse in the NLP world.
Sure.
It's known for its remarkable ability to generate human-quality text.
Okay.
From writing poems and code to composing music and even creating realistic dialogue.
It sounds like GPT-3 is like blurring the line between human and machine creativity.
Yeah, it does.
That's both exciting and a little unsettling. But I'm curious, how do these models actually work? What's like the secret sauce that makes them so powerful?
Well, at the heart of their success lies the concept of self-attention,
Okay.
which we discussed earlier.
Yeah.
Self-attention allows these models to analyze entire sentences at once, understanding the context of each word based on its relationship to all the other words around it. It's
Yeah.
like giving the model a superpower for language comprehension.
So self-attention is like the key
Yeah.
that unlocks the true potential of NLP,
It is.
allowing these models to understand language in a way that was never before possible.
Exactly. And it's thanks to self-attention that we're seeing such incredible advances in NLP
Yeah.
with models that can translate languages, generate creative text formats, and even have realistic conversations.
Right.
But, the field is constantly evolving, and there's always something new and exciting on the horizon.
Speaking of new and exciting, I've heard whispers about the latest and greatest NLP model, something called GPT-4. Is that just hype?
No.
Or is there something truly revolutionary about this new model?
GPT-4 is definitely making waves in the NLP community.
Okay.
It builds upon the success of its predecessors, incorporating new techniques and pushing the boundaries of what's possible with language models.
Okay.
But one of the most intriguing aspects of GPT-4 is its multimodal capabilities.
Multimodal capabilities. What does that mean? Does it mean it can do more than just process text?
Exactly. GPT-4 can process both text and images,
Oh, wow.
making it truly multimodal.
Okay.
This opens up a whole new world of possibilities for how we interact with technology.
Whoa, that's mind-blowing. So it's like GPT-4 can actually like see the image and understand what's happening.
It can?
That's incredible. What are some of the potential applications of this, like multimodal capability?
Oh, the possibilities are really endless.
Yep.
Imagine asking GPT-4 to analyze a medical scan and provide a preliminary diagnosis alongside relevant research papers. This could revolutionize healthcare by, assisting doctors and potentially leading to earlier detection of diseases.
That's a powerful example.
Mhm.
It highlights how these advancements in NLP could have a profound impact on our lives.
Yeah.
But I'm curious, how does GPT-4 actually work?
Yeah.
How does it manage to process both text and images?
Well, it's a bit technical,
Okay.
but essentially GPT-4 utilizes a transformer architecture that's been enhanced to handle multiple modalities.
Oh.
It learns to associate visual features with textual representations, allowing it to, understand the relationship between images and text.
So it's like GPT-4 is learning to see the world through both textual and visual lenses,
Yeah.
bridging the gap between these two forms of information.
Precisely. And this ability to connect text and images opens up, a world of possibilities.
Yep.
From generating detailed descriptions of images to creating new forms of visual storytelling.
It's incredible to think about the potential of these like multimodal models.
Yeah.
But I'm wondering, how do we actually communicate with these models?
Yeah.
How do we tell them what we want them to do?
That's a great question. And it brings us to the fascinating world of prompt engineering,
Okay.
which is all about crafting clever prompts to get desired results from these powerful language models.
Okay.
It's like learning to speak the language of AI.
So it's like giving the model a set of instructions, like a roadmap.
Yes.
For what we want it to do.
Exactly. And the way we structure those instructions can have a huge impact on the model's output.
Okay.
A well-crafted prompt can elicit insightful responses, creative text formats,
Okay.
or even help the model solve complex problems.
Okay, I'm intrigued. But I have to admit, I'm a bit intimidated.
Okay.
It sounds like prompt engineering requires a deep understanding of how these models work.
Well,
Do I need to be like a coding whiz to do this?
not at all. While a technical background can be helpful, prompt engineering is becoming increasingly accessible.
Okay.
There are many resources and tools available
Like
that allow
hundreds.
anyone to, experiment with prompts and see what kind of amazing results they can achieve.
That's reassuring. So where do we begin? Like, what are some of the basic principles of prompt engineering?
Well, one of the most important things is to be clear and specific in your prompts.
Okay.
Think about it, like giving directions to someone.
Okay.
If you're vague or ambiguous,
Yeah.
they're likely to get lost, right?
Yeah.
Same goes for NLP models.
Okay.
So
So instead of saying, write me a story,
Yeah.
we should be more specific.
Yeah.
Like, write me a science fiction story set on Mars in the year 2300.
Exactly. The more specific you are, the better the model will understand what you're looking for.
That makes sense.
Yeah.
Are there any other tips for, like, crafting effective prompts?
Another useful technique is to provide context.
Okay.
Imagine you're asking someone to write a song.
Yeah.
Would you just say write a song?
No.
Or would you give them some background information,
Right.
like the genre, the mood, or even some sample lyrics?
I definitely give them some context.
Right.
It would help them understand, like, my vision for the song.
Exactly. And the same goes for NLP models.
Okay.
The more context you provide, the better the model will be able to generate output that aligns with your intentions.
So context is key.
It is.
What else should we keep in mind when crafting prompts?
Well, it's important to experiment and iterate.
Okay.
Prompt engineering is an iterative process, right?
Yeah.
You might not get the perfect results on your first try,
Right.
but that's okay.
Yeah.
Try different phrasings, different approaches, and see what works best for the specific task you're trying to accomplish.
It sounds like prompt engineering is as much an art as it is a science.
It is.
There's no one-size-fits-all approach.
Right.
And it requires creativity and experimentation to get the best results.
Exactly. And that's what makes it so fascinating.
Yeah.
We're constantly learning new ways to interact with these models and unlock their full potential.
So what are some of the most exciting applications of, like, prompt engineering? What kind of amazing things can we do with this technique?
Well, one area that's particularly exciting is creative writing. Okay. Prompt engineering can be used to generate stories, poems, scripts,
Okay.
even song lyrics.
Oh.
It's like having an AI co-writer helping you explore new ideas and push the boundaries of your creativity.
That sounds incredible. I can imagine writers using this technology to, like, overcome writer's block or explore different creative directions.
Absolutely. And prompt engineering isn't limited to creative writing.
Right.
It can also be used for more practical tasks,
Right.
like summarizing documents, translating languages, and even writing code.
Whoa, writing code. That sounds pretty advanced.
It is. But there are now models that can generate code in multiple programming languages based on natural language descriptions of what you want the code to do.
That's incredible. It's like having an AI programmer at your fingertips.
Yeah.
It could revolutionize software development, making it, like, faster and more accessible.
Exactly. And it's just one example of the many ways prompt engineering is transforming the way we work and interact with technology.
It really feels like prompt engineering is, like, the key to unlocking the full potential of NLP.
It is, yeah.
It's the bridge between our human intentions and the incredible capabilities of these AI models.
Well said. And as these models continue to evolve and become more powerful, prompt engineering will only become more important.
Yeah.
It's a skill that's worth developing,
Yeah.
no matter your field or area of interest.
It's inspiring to think about the future of NLP and the role prompt engineering will play in shaping that future.
Yeah.
It feels like we're just scratching the surface of what's possible.
I agree. And that's what makes this field so exciting,
Yeah.
There's a sense of wonder and discovery,
Yeah.
a feeling that we're on the cusp of something truly transformative.
Well, it's been an incredible journey exploring the world of NLP.
It has.
From its humble beginnings
Mhm.
to the mind-blowing capabilities of models like GPT-4
Right.
and the art of prompt engineering.
Absolutely.
I feel like I've gained a whole new appreciation for the power and potential of this technology.
I'm so glad to hear that. And remember, this is just the beginning.
Yeah.
The field of NLP is constantly evolving, with new discoveries and applications emerging all the time.
For sure.
So stay curious, keep exploring.
Yeah.
And who knows what amazing things you'll create with the power of language and AI.
Well, on that note, I think it's time to wrap up this deep dive.
Okay.
Thanks for joining us on this incredible adventure into the world of natural language processing.
It's been a pleasure. And until next time, keep diving.